right, guys, today we are continuing our learning on percents, and we are going to talk about benchmark percents. But first, we are going to compute each product of multiplying a decimal times a whole number, because you will need this during the lesson. So I'm going to give you 4 minutes to multiply these and find the product, and then we will go over it. Any questions? Go for it. What do I do to multiply a fraction times a whole number? Put it over 1. 1 times 350 is 350. 10 times 1 is? When I'm dividing by 10, all I need to do is take off the zeros at the end. So now I have 35 over 1, and I get 35. Make sense? All right. Again, I put it over 1. 1 times 350 is 350. 100 times 1 is? I can take off 1 0 on the ends. Now I have 35 divided by 10, which gives me 3.5, or 3 5/10. All right, put it over 1. 1 times 670 is 670. 10 times 1 is 10. Take off my 2 zeros, and it gives me 67. And the last one, put it over 1. That's 670 over 100. I can take off the 2 zeros on the ends, and it gives me 6 7/10. Make sense? Any questions? Good, let's turn the page. Last class, we talked about how to convert between fractions, decimals, and percents. So now we are going to use that, and you are going to put these in order from least to greatest. In order from least to greatest. So it is your decision on how you want to do it, but make sure you have a strategy that you are using, and I'm going to give you about 4 minutes to put these in order. Any questions? Yes? Nope. Any other questions? Good. Go for it. Who can tell me their strategy for putting these in order? She turned them all into fractions. Did anybody do it differently? Turn them all into percentages?
Turn them all into percents.
Okay. Nope, you can't do them how they are. You can't just look at them and tell. Or turn them all into decimals. You have to convert them into the same format. They need to either all be decimals, all be percents, or all be fractions in order to accurately compare them. Yes? So that's the first thing we need to do. Convert them all into percents, decimals, or fractions. So I'm going to do percents. How do I turn a decimal into a percent? We talked about it last class. Move it to the right 2 times. So 0.5 becomes 50%. Yes? Then I have 23%. Then I have 4/5. How would I turn that into a percent? Well, could I do that a different way without having to do it twice? We're not doing decimals, we're doing percents. So what would you do to 5 to get to 100? So 4 times 20? So this one is 80%. Good job. Then I have 75 hundredths, and again, we move it twice. So 75 hundredths becomes 75%. Then I have 40%. And then I have 1 over 25. How would I make that a percent? Hannah? So I get 4 over 100, which gives me 4%. Yes? Now, can I take these percents and put them in order from least to greatest? Okay, so what would come first? 4%, then 23%, then 40%, then 50%, then 75%, and last, 80%. So here is our least to greatest because we converted them into the same format. Does that make sense? Any questions? Does everybody understand what we did? Okay, so let's look at Noah and Dylan. They were assigned the numbers 600ths, that's repeating, and 1/10%. But they disagree on which was larger. Noah says that 600ths is less than 1/10, so 600ths is less than 1/10%. Dylan says that since 1/10% is the same as 1,000th, 1,000th is less than 600ths. Who is correct? Explain your reasoning. So I want you to reread that because that was a whole lot of numbers. And then I want you to tell me who's correct. Is it Noah or Dylan, based on what we know about percents and decimals? You have about 3 minutes. Go for it. Who thinks Noah was correct when he said that 600ths is less than 1/10, so 600ths is less than 1/10%? Okay. Who thinks Dylan is correct? Okay. Dylan is correct. And we know that because these are not in the same format. One is a decimal and one is a percent. Yes, it has a decimal in it, but it is a percent. So I have 0.06 as my decimal, and then I have 1/10%. How do I turn that percent into a decimal? Hannah? To the left twice, and empty buckets get a 0. So now I'm at 600ths compared to 1,000th. So does that show you that 600ths is more than 1,000th? It should. If I have 6 cents, or if I have 0 cents, because I can only have 2 numbers after the decimal when there's money, right? If I use that 1 to round, it doesn't go anywhere. So I either have 6 cents or 0 cents. Which one's more? 6 cents. Make sense? So 600ths is greater than 1/10% because 1/10% is 1,000th as a decimal. Any questions about that? You have to pay attention to what they are telling you. All right, the next one, number 3, is just like number 1, except you have a whole lot more numbers. So you need to pick which format you are going to convert them to. And here is my hint. I would do decimals for this one. And then put them in order from least to greatest. Any questions? All right, this time we're going to give you about 8 minutes because there's so many numbers. And then we will come back and discuss. Yes? All right, go for it. Least to greatest. 3. Okay. So I gave you a hint at the beginning to turn all of them into decimals. So 0 is going to stay the same, and 99/100ths will stay the same. How would I make 1/9 a decimal? Not multiply. Yep. Say that backwards. You're dividing the top number by the bottom number. Your numerator by your denominator. Make sense? Can 9 go into 1? No. So I add a 0 and a decimal. 9 into 10? How many times? That leaves 1. Add a 0. Can it go into 10? How many times? So what do you notice is happening? It's repeating. So I just put a line over it, and that is my decimal. Make sense? All right. How would I make 17/20ths a decimal? If one fraction works that way, do we think the other fractions will work that way?
Yes.
Come on, people. 20 into 17. Can it go?
Yes.
No. So I add a 0 and a decimal. 20 into 170. How many times? Isaac? 8. That's 160. Leaves 10. Add a 0. 20 into 100. 5. That's 100. So I get 85. 85 hundredths. Make sense? All right. What do I do to a percent to make it a decimal? I'm on 95%. How do I make it a decimal? You're reversing it. You know your decimal's at the end of a whole number, and you're moving it to the left twice. So I get 95 hundredths. And this one I would get 25 hundredths. Then I have 3/8. How would I find the decimal for 3/8? Divide the numerator by the denominator. So 8, can it go into 3?
Yes.
Add a decimal and a 0. Can it go into 30?
Yes.
How many times? 3, that's 24. Leave 6. Add a 0 into 60. How many times will 8 go into 60?
7.
7, that's 56. Leaves 4. Add a 0 into 40. 5. And that gives me my 0. So this is 375 thousandths. Then I have a percent, so I move it twice to the left and I get 70 hundredths. Twice to the left and I get 43 thousandths. And the last two are already done for me. So now we have all decimals. So let's start with our last place value. Which one's going to go first? 0. Actually, not 0.
Oh, wait, yeah. What? Oh.
Yes? Yes? Nope.
Oh, the 0.37.
I'm looking at my tenths place. I'll put this. Okay. Tenths place. Which one of those is smallest? The 9, the 1, the 8, the 9, the 2, the 3, the 7, the 0, the 8, or the 6? 0. So that's where I need to start. All right. What comes next after that? Looking at the tenths place. 1/10. Then 2 25 hundredths. Then nope. 375 thousandths. Then let me cross out what I've used. This, 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 and this. So what's next? 0 and 64 hundredths. Cross it out. 0.70, cross it out. 0.81. Then 0 and 85 hundredths. Then 0 and 95 hundredths. And 0 and 99 hundredths. So let's count how many numbers we started with. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's make sure we have all 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Good. And that is in order from least to greatest. Any questions? Hello?
No.
All right, so I'm going to go back and put what they are worth for each, what they started out as on each of them. So this is 4.3 is what it started with percent. 1/9, 25%, 3/8. That one's the same. 70%. That one's the same. 85. 17/20. 95%. And that one's the same. So that is how they should be in order from least to greatest. Make sense? All right, turn your page.
Did you talk about the dividing by 9?
Nope.
Okay. Okay, guys, pull out your vocabulary sheets. We have a vocabulary term here for you. And your marking, your highlighters / marking pencils. This is actually a really critical concept. This is one that you will be using a lot in your life. Module 2, yep. Topic 2 and 3. A benchmark percent is a commonly used percent, such as 1, 5, 10, 25, and 50, and 100%. Those are the ones that we will commonly use. So we call those benchmarks because it works really well to get to other ones based on your benchmarks. One thing I wanted to add real quick, kind of a quick sheet from the previous page, guys. Anytime I have a fraction with 9 in my denominator, it's actually super easy to turn it into a decimal because it's whatever my numerator is as a repeating decimal. If it's 2/9, it's going to go forever. Okay? Now, ironically, 1/3 is actually 3/9. So that one is 3 forevers. Okay? So if you have a 9 in your denominator, whatever your numerator is going to repeat forever. Speaking of the fractions, if we look at benchmark percents, we can also look at the fractions associated with them. So if I have 100%, that's 1 whole. Everybody good with that? Yeah. So if I want 50% of that, what fraction is that? It's 1/2. If I want 25%, what fraction would that be? 1/4. If I wanted 20%, what fraction is that? 1/5. If I wanted 10%, what fraction is that? Make sense? Now that you see the visual model, can you understand how that works out? Okay? So here's our deal. We're going to look at these benchmarks, and we're going to do relations to each other to make the numbers roll easier. Because when you understand the relationships, then the math itself becomes very easy. So how is 50% related to 100%? What do you think? Good. It's 1/2 of 100. Or another way I like to think of it is, if I take two 50s, that's 100%, right? Do what? Okay, Riker, we'll tell your mom to listen to the video and hear you being silly. How is 25% related to 100%? Ava? It's 1/4 of 100. Or, again, another way I like to think of it, if I think of it in terms of how do I get there, 4 25s gives me 100%, right? What about, now that we've broken it down, could I relate 25 to 50? How would that relation go? What do you think, Isaac? Good. So it's half of 50%. Or we could say 2 25% give us 50%. You want to do the next one, Isabella? Question? Just have your hand up for fun. Okay, what about 10% related to 100%? What do you think, Lena? It's like 1/10, right? So it's 1/10 of 100, or I could say 10% gives me 100%. What about 50%? How's 10% related to 50%? Nash?
10 times 5 is 50.
10 times 5. So I could say 5 10% is 50%. How would I do it as a fraction? Alina?
It's 1/5.
1/5. So it's 1/10 of 100 or 1/5 of 50. Am I good with all these relationships?
Yeah.
Seeing how we're putting them together, does it make sense?
Yeah.
Because if it makes sense, then the math becomes easier, which is really what benchmarking percent is about. One thing we do need you to remember, that 1% is the same thing as 100th, right? So if I do 1%, all I'm doing is moving my decimal twice to the left. Why? Because it's just like dividing by 100. So now, this one wasn't on the tape diagram, but let's see if you can still continue the pattern. How would 5% relate to 10% then? Brantley? It's half of 10%, right? Or we could say 2 5% gives me 10%. Could we go all the way down to 1% then? What about 1% to 10%? 1/10 of 10%. Or we could say 10 1% gives me 10%. Can we also go down 1 to 5%? What do you think? It's 1/5 of 5. Or we could say 5 1% gives me 5%. Any questions on any of that? I'm hoping that should be relatively like, yeah, okay, that makes sense, Mr. Moore. Nothing hard here, right? Now let's look about using that thought process. So we're going to put actual numbers to it. So we're going to use our benchmarks to determine each value, but our 100% is going to be 600. So in other words, I'm using 600 as my baseline. That's what 100% is. So now, how would I find 50% of 600? To me, the easy way is saying it's half of the whole thing, right? So half of 600 is going to give me 300. Does that make sense? Okay. So we started you on the road. You have 4 more that you need to do. So you're going to do 25, 10, 5, and 1. I'll give you a hint. 25 is half of 50, right? So you don't always have to go to the 100%. Once I have benchmarks, you can use those benchmarks to find other benchmarks. So we'll give you guys about 5 minutes to finish up the next 5. Go ahead and go. Okay, guys, so we break this down. I'm just going to talk to you the way I would do this, because this is real life stuff. If I've already figured out what 50% is, what's the relationship between 50% and 25%? It's half. So half of 300 is going to give me 150. Could I go back to the 600? Yes. So it'd be 1/4 of the 600. I'm going to get the same answer. But the idea on benchmark percents is to make it easy for yourself, guys. So I will be quite honest. Rather than doing 1/4 of 600, for me it's easier to say, well, half of that's 300, half of that's 150. Rather than trying to do the 600 divided by 4. If you've got that math knowledge that you can divide that by 4 easily, go for it. But a lot of times it's easier to do half and half. Okay? 10%. Guys, this is the easiest thing we're going to ask you to do all year. Because 10% means I move my decimal what? How many times? Once. So literally all I do is I take my number, I move my decimal once. It's 60. 10% of a number is one of the easiest things you're going to do. The only thing that is basically just as easy is 1%. Because then instead of once, I'm moving it twice. Now that I have 10%, what's the relationship to 5%? It's half. So all I'm going to do is I'm going to take half of 60. So it tells me that one is 30. Could I go back to my original? Yes, I could do 1/20 of 600. That goes away because we wanted a 30. So it's going to get the same answer, but again, make the math easy for yourself. That's what benchmark percents are about. 1% is the second easiest thing we're going to give you to do all year, because all I'm doing is moving my decimal twice. Make sense? Okay, this next part. Ben was going ahead, like usual, rather than doing what he's supposed to. And he saw we're supposed to use a calculator. Guys, I'll be quite honest. It is stupid to use a calculator on this, because it's actually faster to do it manually. Anybody doubt me on that one? Who thinks it would be easier to use a calculator to figure this out? Raise your hand. Okay, I'm not going to give you a calculator, but envision yourself trying to put the numbers in the calculator to divide 1% times 2.8, right? Watch how fast I can do this. All you're doing is moving your decimal, guys. Is there anybody here that can't move your decimal twice? Now, make sure you're doing it in the right direction. If I'm going percent to decimal, I'm moving it to the left because I'm actually technically dividing it by 100. What about if I'm doing 10%? Wow, this is really hard. Guys, are you seeing what we're doing? Good. I will give you guys an additional 1 minute to do the next 6. Go. Okay, 30 seconds. Okay, we're going to go fast because you should have gone fast. 1%. I'm moving it twice. So all these, I'm just moving it twice. Remember, empty buckets get zeros. 10%, I'm just moving it once. It doesn't matter where my decimal is. If it's 10%, I'm just moving it once from where it is. Are any of those difficult? It is too difficult for Riker. For I think the rest of us is pretty easy. Okay, guys, let's go to our next page. Okay, please quiet down. Well, guys, we're recording. We're doing way too much counting for a recording class. Please stop. Okay, 5. We've already done about all that. We've already talked about all that. But if we were to actually write that into a rule, what rule would we say to do 1%? What were we doing?
Slide it over twice.
Which way?
To the right. I mean,
The direction is critically important. Left. Move to the left. If it's 1%, I'm going 2 places. Okay? What about doing 10%? Isaac? Good. Move to the left 1 space. Guys, 1% and 10% of the numbers are super easy. You just have to be comfortable with just moving your decimal. That's all it's doing. Yes?
So every time you're adding 0 to the percent, you're taking away 1 space?
Yep. Okay? So now that we've done those, we'll give you a chance to practice again. Pay attention to whether it's 1 or 10%, and pay attention to where the decimal is. Again, this should take you guys about 1 minute. Go ahead. Okay, our 10%, we're just moving once. All the rest of the numbers remain the same. So wherever our decimal is, we're moving it once. 1%, we're moving it twice. Don't forget, empty buckets, get zeros. We have to have every place accounted for. Questions on 1s and 10%? Because that's going to make the basis for the next part we're going to do.
Sawyer, what's up?
I'm sorry? Because 1% is 1/100th. 10% is 10 100ths or 1/10. So in a 10%, I'm only moving it to 0.10. Okay. One way in real world that people do this is to figure out tips for servers. So Akuro eats at the restaurant and he wants to leave a 15% tip. He says I can do 10% of any number easy, right? And then do half of that, which is equal to 5%. Then I add those two together to get a sum of 15. Is that reasonable? Yes. Guys, I literally do this almost on a daily basis. So yes.
Hi, why are you talking? Stop.
If I have those two pieces, 10% plus 5% gives me 15%. So now let's do it real life. If I'm doing a bill of $16, how can I do 15%? What's 10% of 16? Of 16.
10% of something.
divided by
You're moving the decimal 1 place.
Okay. 5% means that it's half of that. What's half of $1.60? 80 cents. And then for my 15, I put those together. My decimal comes straight down. So 15% is $2.40. Does that make sense? Okay, I hope so, because now you guys get to do that on the next 3. So calculate the tip, round to the nearest hundredth. I'll give you a hint, that's going to be part B. A and C will work out well. B is going to take you a minute. Because we're recording, we can give you guys about 4 minutes to do this one. So I had to shut you guys a little early so we can get the recording done, but this should not be too difficult. 10%, I'm just moving my decimal once. That's 240. 5% is half of that, or 120. My 15%, I put those two together. 0, 6, 3. $3.60. 10%, I just moved my decimal once. So that becomes 3.256, which makes the 5% a little more difficult because it wasn't an even number. But you should still be able to do half of that relatively easy. That's going to be 1, 6, 2, 8. I put those two together, 14, 8, 8, 4. This is the one we have to round to the nearest hundredth. So the 4 means that the 8 stays the same. So that's going to be $4.88. And then our 47. 10% gives us 470. Half of that is going to be 235. Put those together, and we get 705. Guys, I do this like almost every day. My wife and I eat out quite a bit, so I do a lot of these calculations, and this is exactly what I do. So it makes sense for you guys. Okay, we got to look at this one because this is going to be very similar to your homework. And this is using your baseline percents to figure out one that's not a baseline. And all we're going to do is we're going to take tens, fives, and ones and figure out how many of each do we need in order to get the percent that we need. So I'm going to take 18% and I'm going to break it down into tens, fives, and ones. So how many tens would I need to get to 18%? 1. So if I'm used 10% already, that means I'm now at 8%. So how many fives do I need? 1. And how many 1% would I need? 3. So if I put those together, I now have 18%. Does that make sense? Okay. If I do 25%, how many tens?
No.
2. How many fives? 1. Do I need any ones? No. What about 37%? How many tens?
3.
3. How many fives? And how many ones? Does that make sense for everybody? Okay. Because if that makes sense, this next part is really what we're going to be doing on the homework. So to get 27%, I need 2 tens, yes? Okay, so that means 2 of 10% means I move my decimal once. So that's 8 4/10, or 16 8/10. I need 1 5%, and be careful to make sure you use the 10% to take half of. So half of 8 4/10 would be 4 2/10. So I'm going to put 4 2/10 under that. And then I need 2 1%. 1% means I'm moving it twice. So that's going to be 2 times 84 hundredths, which is going to be 1 68. So I put in trailing zero so that I can add up my columns. It gives me 8, 10, 16, 10, 12. So 27% is 2268. Does that make sense?
You went too fast.
I know I went fast because we're trying to get it in the recording, which we got about 2 minutes left.
Overall, yeah.
Okay? If nothing else, you can go back to the recording and look at it again. But all you're doing, guys, break the percentage down into your baselines, tens, fives, and ones. Put together as many each as you need. So let's go look at our homework and see how that relates.
Quit talking.
We're on 279. Explain how the benchmarks work in order to estimate the values. Guys, it's just getting you close. Here's where it's going to get a little tricky. So let me erase that. That was from last class. So use your benchmarks to find the amount. So what you're going to do is you're going to take the percent off of here, 65% for candy, right? And I'm going to say, okay, well, that's 6 tens and 1 5, correct? And then I'm going to take the amount that they gave me. I'm going to take 10% of that. So that's going to be 6 times 6 40s. And 1 times half of that, which would be 320. And I'm going to add it together. Make sense?
Yeah.
So you're going to do that for all 4 of those. Then part 2, you're going to do kind of the same thing, 42%. But now the number is 4,500. So that's going to be 4 tens and 2 ones. And then you're just going to put them together. On the back page, 280. Now you're doing 15%. They gave you relatively decent numbers for all of them. The only one that's going to get a little tricky is on that bottom row, DEF, but none of them are that complex. Questions on any of the homework, guys? Okay? Should be relatively easy. The key is getting comfortable. 1%, I move my decimal left twice. 10%, I move my decimal left once. Good luck, guys.